course, this question is based on mole. We have established earlier the meaning or the definition of mole. We said here in one of our videos here that mole simply means the amount of chemical substance that contains as many elementary particles as there are in 12 grams of carbon 12 isotopes. And of course, mole is also the SI unit for measuring an amount of chemical substance. Alright, let's take a look at this question. The question says, how many moles of potassium ion are there in 0.12 dn cube of 0.15 mole per dn cube of potassium tetraoxo sulfate 6? This question is hard, right? No. It is not hard. It's very, very simple. It's just for us to put ourselves through. Alright? If you see a question like this, please don't panic. Please don't panic. We already know, we have established earlier that how do we find mole? Let me say solution. We say that mole is equal to mass all over molar mass. But in this case, this formula cannot work for this because this is in solution form. You can see we're giving volume in dn cube and we're also giving the concentration of the salt in mole per dn cube. So another formula we can use to calculate mole of any substance is what I'm going to give ourselves. Okay, another formula we can use to find mole is this. Mole can also be gotten this way. Mole, let me put it this way. Mole is equal to concentration. Concentration is what is given usually in mole per dn cube times volume. And of course, that volume is going to be in dn cube. Times volume in dn cube. Times volume in dn cube. If you don't want to say it that way, you can say that mole is equal to concentration times volume all over 1000. Because whenever you have volume in Cn cube and you divide it by 1000, you have changed your volume from Cn cube to dn cube. So, in a simple term, we can say that mole, which is represented as N, is equal to concentration. And of course, this concentration is usually measured in mole per dn cube times volume. And the volume is usually going to be in dn cube. Are we going or moving together? Alright, let me erase this and establish, put it back. Okay, so we are going to use the second formula that says mole. M here stands for mole. Capital C here stands for concentration in mole per dn cube. While capital V here stands for volume in dn cube. Volume in dn cube. So the next thing we are going to do is just to ionize this salt. Let us ionize this salt. So when we have potassium tetraoxo sulfate 6, which is K2SO4 aqueous, meaning that this salt is dissolved in water. This salt, because it's an ionic salt, whenever it is dissolved in water, it is going to split or dissociate or ionize to form its ion, its component ion. The ions are going to be potassium ion, which is still inside solution aqueous, and also tetraoxo sulfate 6 ion, SO4 2 negative. This is also aqueous. Alright? But let us balance the equation. Remember, for 1 mole of potassium tetraoxo sulfate 6, there are 2 atoms. And so for us to balance potassium on the right, we put 2 here. The equation is now balanced. That is the first step. That is the first step we are going to apply. Now, let us go. We are now going to look for the number of mole. We know that this is 1 mole. 1 mole of potassium tetraoxo sulfate 6 is giving us 2 mole of potassium ion and also 1 mole of tetraoxo sulfate 6 ion. Alright, so we are going to find the number of moles present in this volume of this salt here, the concentration given here. So we have said that number of moles is equal to concentration times volume. So how do we find our number of moles here? Number of moles here, the concentration was given to be 0.015 mole per dn cube. This is it. This is the concentration. Alright, we multiply by the volume. Volume was given to be 0.1 dn cube. So let us see what we have here. 0.015 times 0.12. We are going to have 1.8 times 10 raised to the power minus 3. Mind you, in some of the calculator, me, I am using cash natural display. In some of the calculator, especially Casio, you may not see the answer being displayed like this. The answer may display in form of fraction or decimal. So you see answers like 0.00, okay, that is 318. So this is how it may appear, and then many other numbers there which are not significant, maybe 0.00000. Alright, so in some calculator like natural display, the answers will be displayed like this, and in some it will be like it is still the same thing, just that this one is in standard form, whereas this one is in decimal fraction or decimal form. Alright, so this is the number of mole. This is the number of mole of this salt that is present in this volume. Okay, this is the number of mole. So permit me, let me put it down here. That we say that is 1.8 times 10 raised to the power minus 3 mole. Okay, so that I will erase this. Let me erase this. Let me erase this. So if the number of mole, that simply means that the number of mole of this is 1.8 times 10 raised to the power minus 3. If 1.8 times 10 raised to the power minus 3 of this dissociates, it will give us the same thing as this, 1.8 times 10 raised to the power minus 3. But there are two of them there, since there are two moles of potassium ion, so we'll multiply it by 2. Okay, and of course this is still going to give us the same thing here, still going to give us the same thing here. Going to give us 1.8 times 10 to the power minus 3. But this doesn't concern us. Our concern is the number of moles of potassium ion. So let me bring that again. The number of moles of this salt here from our calculation here, when we establish the fact that number of moles equals the concentration times volume, gives us to be 1.8 times 10 to the power minus 3. So if 1.8 times 10 to the power minus 3 ionize the solution, it is going to give us times 2 of that, because there are 2 moles of potassium ion in potassium tetraoxosulfate 6. Alright, so how then do we now get the number of moles of potassium ion in this concentration or volume that we are given? So we are going to multiply 2 by the number of moles we have gotten, 2 times 1.8 times 10 to the power minus 3. Let us see. This is going to give us 3.6 times 10 to the power minus 3 mole. 3.6 times 10 to the power minus 3. So from our explanation here and calculation, our correct answer is option letter B. Option letter B. Please, if you have any problem on how to calculate the number of moles, please give me a DM. Follow my YouTube channel, Eugene TV. You can also watch my videos on YouTube, TikTok, Eugene TV 101. Thank you and bye for now.